MOA is a critical component of shooting accurately with any optic, but it's one of those concepts in shooting that can be very intimidating to learn when you're just starting out. So in today's video, I want to take the theory of MOA and how to apply it in real life down on the range and break it down for you and explain it as best as I can, so hopefully you have an easier time learning about MOA and how to apply it than I did. So what is MOA? Well, MOA stands for minute of angle, which is kind of a weird term, so let's break it down. So the minute part and minute of angle isn't actually talking about time. It's actually just a fancy way of saying 1/60th of something. Best analogy I can think of for this is like how 1 minute is equal to 1/60th of 1 hour. But again, we're not talking about time, we're just basically saying 1/60th of something. Now the angle part refers to a portion of a circle which has 360 degrees. So when we're saying minute of angle, what we're actually saying is 1/60th of 1 degree in a circle. Now here's the key thing to keep in mind. MOA is not a linear measurement. It's actually an angular measurement because we're measuring the angle between two things. Imagine if you had a laser pointer that shoots two laser beams and you aim them both at the exact same spot on a target that's 100 yards away. Then you gradually begin to angle the lasers apart until the angle between them at their origin is 1/60th of 1 degree. With the lasers spread apart, there will be a linear distance between the spots where they impact the target. This distance comes out to exactly 1.047 inches with the target placed at 100 yards. This means that 1 minute of angle is equal to 1.047 inches at 100 yards. Now that 1.047 inches is generally just rounded down to 1 inch for most purposes, so we can think of 1 MOA as being equal to 1 inch at 100 yards. Okay, 1 MOA, 1 inch at 100 yards. Easy peasy, right? But then what happens when the distance to the target gets even bigger? Let's say if we push it back to 200, 300, or even 400 yards. We're aiming our lasers at the target with that same 1/60th of 1 degree angle between them at their origin. Then we move the target back so that it's now 200 yards away from us. With that increased distance, a funny thing begins to happen. We get this rare optical illusion that makes the target look like a huge subscribe button. Quick, shoot that subscribe button right now before it gets away. All right, but seriously, with the increased distance to the target now, the lasers are able to spread further apart even though the angle at their origin didn't change. With the target moved back to 200 yards, the lasers will hit the target with a distance of 2.094 inches between them. Again, this exact number is usually just rounded, and that's going to be down to 2 inches in this case. But did you catch what happened here? Our MOA value of 1 didn't change as the target was moved from 100 to 200 yards. And the lasers still had that same 1/60th of 1 degree angle between them at their origin. But that same MOA value translated to different distances as the range to the target increased. If we take this a few steps further, we're going to find that 1 MOA will equal about 3 inches at 300 yards, then about 4 inches at 400 yards, so on and so forth as the range to the target keeps increasing. Okay, great. So now we know the theory behind minute of angle, but how do we go about taking this theory and actually apply it in real life down on the range? The first thing we want to do is start thinking in MOA increments. So if the range to the target is 100 yards, I'm going to be thinking in 1 inch increments, and then I'll be thinking in 2 inch increments at 200 yards and so on. Let's say that I'm trying to zero an optic at 100 yards, and I shoot a group, and that group ends up being 1 inch low, again, at 100 yards. I instantly know that I need to adjust my optics elevation up by 1 MOA. Now this is where we really have to know our optics, because one click on your adjustment dial is going to equal different MOA values on different optics. For example, I'm running an Osprey ST3 scope on my Remington 783 right here, and on this scope, one click on my adjustment dial is going to equal 1/4 of 1 MOA. But again, that's going to change depending on the make or model of optic that you have. Like let's say 1 click could equal half an MOA on your scope, or even 1 whole MOA. So you just got to know your equipment, and you got to know what MOA value 1 click on your dial is equal to. So if my group is 1 inch low at 100 yards with my scope, I'll need to turn my elevation adjustment up by 4 clicks. Now this is a pretty straightforward example just to demonstrate the general idea behind what's going on here. But when you're actually down on the range in real life trying to zero your own optics, those numbers are probably going to end up being pretty messy. So here's a more real world example. Let's say I want to zero my scope at 300 yards and I shoot a group, and that group ends up being 5.5 inches high and 4 inches to the right. First, I'm going to be thinking in 3-inch increments since 1 MOA equals about 3 inches at this range. Then I'm going to figure out how many of my 3-inch increments fit into 5.5 inches. That comes out to 1.83 repeating. Then I'm going to take that 1.83, multiply it by 4. Since each click on my scope is 1/4 of an MOA, and it's going to take 4 of those clicks to adjust by 1 MOA. 1.83 times 4 equals 7.32. And since 7 is the nearest whole number, that means that I'll need to dial my elevation adjustment down by 7 clicks on my scope. And then I'll just simply repeat the exact same process for my windage adjustment. So 1.3 repeating of my 3-inch increments will fit into that 4 inches to the right that my windage is off by. Multiplying 1.3 by 4 gives me 5.2. So then all I got to do at this point is simply adjust my windage 5 clicks to the left. All right, if you enjoy this kind of content, be sure to leave me a comment down below letting me know if you want to see more videos just like this in the future.